All right, let's take another look at some radical functions. So this one wants us to identify and compare the domains and ranges of the functions in each pair and explain why they differ. So let's look at our first equation, y equals 4 minus x squared. I think the easiest thing to do is probably to just sketch a little graph out first. Now this is in vertex form, so I'm going to rearrange it so it's more obviously in that form. So there we go. So from that I can see that my vertex is 0, 4. And because my a value is negative, I know my graph is going to be going down. So I've got a graph that looks something like that. I can already see what its domain and range is then. So to my domain, well, there's no restrictions on my x values, so they go from negative infinity to infinity. For my range values, it's going to depend on the vertex. So it's a maximum, meaning that we have a negative infinity to 4. And we do include 4 in that set. All right, let's take a look at our second graph then. So this one, we're going to square root all of these values in here. Again, we cannot square root a negative height. So the important ones are going to be the y-intercept, so where it crosses. And then also this vertex. So the square root of 4 is 2. If this is the maximum here in our parabola, it's also going to be a maximum in our radical. So this is actually going to be 0, 2. And so we're going to have a graph that looks something like that. It's just a sketch. One thing to note though is we don't actually know what these y-intercepts are yet. So I'm going to go and let y equal 0. And now we could do it to either of these. I think this is the simpler graph. So I'm going to go our equation. So 0 equals negative x squared plus 4. Add x squared to both sides. And then square root both sides. So you get plus or minus 2. So that means I have y-intercepts at 2, 0 and negative 2, 0. Now I should be able to do my domain of my blue graph, or our radical function. So my domain is going to be between the two y-intercepts. So from negative 2 to 2, again, these are included. That's why they're square brackets. And then my range. So my minimum is 0. And my maximum is 2. Okay, part 1 done. We've identified it. Now we need to compare how these actually differ. Now remember, comparing though is differences and similarities that we can find. So the ranges, and the domain is quite a bit more restricted for our radical. And it does ask us to explain, well, why is that then? Well, it's more restricted because as soon as we root something, we've introduced this restriction x must be greater than 0. Or whatever happens to be inside of our radicand, if it were. So then there's something that right away, that's why these are so different. Now we need to make sure we don't forget to actually find a similarity between these. It's a little bit tough, but I would say the best one I can see is that they are both, from negative 2 to 2, is both an acceptable domain for both equations. Let's look at a similar question. Identify again and compare their domains and ranges. So we've got these two equations. Again, I think the easiest thing is going to be to sketch this. This is a parabola. So let's just go sketch our parabola. It's already in vertex form for us. So I know it's going to be 0, 24. So 0, 24 is our vertex. And then I'm looking at my a value, and it's positive. So I'm going to have a graph that looks something like that. Now we can go and write the domain for that then. So our domain, well, there's no restrictions on the x. And we do have some restrictions on our y value, or our height. It's a minimum, so that's going to be the lowest point, so 24, and that goes all up, the way up to infinity. Done. Next, the radical of that function. Well, normally you can't square root a height. That's negative. Well, there is no negative heights here. So actually, we can take all of these points and we can square root them. So then if I estimate, maybe I've got a root, and it's going to look something like that. And this point here is going to be 0, now again, it's taking the root of each number, or each height, so we're going to take the square root of 24. So that should be enough information to actually do our domain and range then. So my domain, well, that's easy. There is no restriction on it. It can be any of the x values. So it's all real numbers. Now our range, we've got to be careful here. We see this square root of 24. We should actually check, can we simplify that? Oh, yeah, we can divide that by 4. So we get 2 square root 6. Okay, so then we have 2 square root 6 as our minimum. And this goes all the way up to infinity. Okay, perfect. Step 1, done. Identify. Compare. Comparing is easy here. The domains are the same. Our ranges are different. The reason our range is different is because it's taking the vertex and actually square rooting it. We're square rooting each point. So our minimum still is in the same x location, but it's taking the square root of it. So that's why it's different. Now, the reason that the domains are the same is because there's no restrictions occurring on the graph. It doesn't ever cross the x-axis, so there is no negative heights. Now let's look at one last problem, a word problem. A 25-foot long ladder leans against a wall. The height, h in feet of the top of the ladder above the ground, is related to its distance, d in feet from the base of the wall. Write an equation to represent h as a function of d. Okay, let's draw a picture first. So I've got a nice, this beautiful wall. Maybe you're outside taking down your Christmas lights, and you've got a 25-foot ladder. Now we need to make some variables for here. We're comparing our height to our distance. So our height is h, and our distance is d. Now we do have to be careful. This wants it in function notation, so function of d, function of x. So that means this h is going to be our height. So that's nice. That's going to be our y value. Now you should notice right away, hey, this is a right triangle. So Pythagorean theorem. So we got d squared plus h squared equals 25 squared. The question is, which one should I solve for? Well, we've already kind of shown that I need to find my y value, or in this case, our h. So we're going to solve for h. So I'm going to subtract d squared from both sides. I'm just going to write this in vertex form already. And then 25 squared is 625. And then I'm going to take the square root of both sides. So I end up with the plus or minus the square root of d squared plus 625. Now, I already don't like this. We can't have a negative square root or negative height. So I would get rid of this right away. And I would put a little note there saying we can't have a negative height, so therefore I'm getting rid of this. It does ask later in the question to identify why you wouldn't. I would just do it right now. Okay. Now it also wants it in function notation. So h of d is equal to the square root of negative d squared plus 625. Awesome. First part done. Wrote an equation. It's in function notation, and h is our y value. Next, provide a sketch of the function and identify the domain and range. So let's just do the function inside of here, our parabola first. So we'll just make a nice little... It's already in vertex form for us, which is nice. I see that I have a 0, 625. 0, 625. This is very much not going to be to scale. And then I see how I have a negative a value. So our parabola is going to look something like this. Next, to get the... before we do that, we should label this. We don't want somebody thinking we don't know what we're doing. So we're going to put y equals... And now this is just negative d squared plus 625. Be very explicit in what you're doing. All right, next. Let's actually do h of d then. So we're going to take the square root of anything possible. However, we can't have a negative height, and we can't have a negative distance. So I'm not even going to graph this part. I'm only going to graph from here. So this is where the ladder is leaning fully up against the wall, and this is where it's fully laying on the ground. Now I take the square root of 625, and I get 25. So we got 0, 25. So there is our highest point. Now we do have to find our y-intercept then. So I'm going to let y equal 0, and I'm going to take this equation and just solve for what d would be in that case. So negative d squared plus 625, add d squared to both sides, and then square root both sides. Now you're going to see that we get plus or minus 25, which does make sense because right here would be our negative 25, 0, and this would be our 25, 0. Now, again, I'm not going to worry about this part. I can't have a negative distance. So then I'm not going to include that in my graph or my domain. So my domain is just from here to here. Okay, so domain. So we could have 0 distance to a maximum of 25 distance, so the ladder's laying on the ground. For our range, we could have that ladder fully laying on the ground or fully laying up against the wall, so for the max of 25. So there we go. We've identified the domain and range. Next, explain how the shape of the graph, the domain, and the range relates to the situation. Well, we've already kind of talked about that. I got rid of parts of this graph already because I said you can't have a negative distance or a negative height. So therefore, I can only have this little part of this graph right here. That's it. And it's because we can't have, with this ladder, it's not going to go a negative distance somehow. And that's the situation they're talking about. So whenever you answer a question like this, make sure you actually include the situation like, it's a ladder. You can't have a negative distance from the wall. It's not possible.